Okay, 5-3, if you would please
that
wrap up your conversations and then pay attention up here. We were looking at log functions and graphs. This is important to know how to go back and forth between a log and the exponential equation, because what we're going to do today requires this. So I hope you were understanding this yesterday. Remember, the base of the log is the base of the exponent, and if you use the technique that I use where it's on the left side of the equal sign, the other two switch. We also learned yesterday that some logs cannot be evaluated because they cross over into imaginary numbers. And in that case, you just say not real. We don't actually go and evaluate it. This slide right here is introducing you to what's called natural logs, natural logarithms. And I want you to draw a big arrow, and then I want you to do a cursive, lowercase l, and an n. That's how you're going to see me write it. It is ln because nl just didn't have a good ring, I guess. They decided to make it ln. It stands for the natural logarithm. You have a highlighter. You may want to highlight this right here. If you don't have a highlighter, then just come over here and make a note that ln of x, that's the way you read it, is the same thing as log base e of x. ln of x is the same thing as log base e of x. So if I ever give you a log base e expression, you could take log base e off and just write ln, or vice versa. ln, if you look at your calculator, you have an ln button.
Yeah, that's where I need to get up.
You have an ln button. If for practice, if I said evaluate ln of 53, you would just push the ln button, type 53, it will produce the decimal. I need you to take away from this that ln and e are inverses. Just like log and exponential expressions are inverses. So the takeaway here is you've just learned 4 functions, and they're paired in. Y'all like how I did that? That was smooth. I said 4, and they're paired. Inverses. ln and e are inverses. Log and exponential are inverses. That was pretty impressive. That was my left hand. Like the right hand. Never mind. That was, yeah. Y'all know what I'm trying to do?
Yes.
Yeah. The right hand can't do it.
This thing?
I'm trying. It's just you. It's just me. I did it. But
It's just you.
I can't do it on my left hand.
the V is not as prominent when I actually get it done on that. I don't know why. Now everybody can check. Can you do it?
Oh.
Hey.
This means part of Scientology.
Are you kidding? Callie said she can't do it either.
Is it?
There's always this one.
On my left hand,
Or this one.
No, because I got my left hand to do it, but I can't do it on my
Me
right.
personally, I'm
I can do it on my
My
right.
ring finger is not moving at all. Like the
Oh, it can't.
No, I can't do it.
You're getting so distracted, I don't know if you care.
actually do
I can't do
my
it.
left
I
hand
can't do
according to
this. Like
Anyways, I can do it that way. All day long.
My life's right one.
Brody, can you pull that filing cabinet and move this a little? All right. So now that we all know tricks with our,
With our
welcome to Earth.
hands.
Go to this slide, please. looks familiar, but this is the special cases for LN, just like we had the special cases for log. If you ever are asked what is the ln of 1, it is 0. The ln of 1 is 0. And ln of E, I want you to box this one in, then I want you to draw an arrow to it, and I want you to write memorize. Your life will be easier if you can remember that the ln of E is just 1. Which means you would take the ln of E out and you would replace it with a 1.
Wait, aren't
Yes.
L and E inverses, so they just cancel each other out?
So that's why it's 1. It's because, remember, ln stands for log base E. And if it's of E, remember we learned that when the base and the of match, it's 1. So life is easier if you'll remember ln of E is 1. Okay. Let's evaluate these. You are using your calculator. You're going to 4 decimal places. I don't think you really need help with learning how to type it in. Type it in, write it down, and let's check our answers. You have 5 practice problems. Oh, yeah.
Said 4 decimal places?
Yes. So
Oops,
that
it's the
means-
following time close.
That means tomorrow you'll need to too. Okay. Is there anyone that's going to be leaving early from my class because of work base? 2:05 is when my class ends. Okay.
Error.
Did you get number or A right?
Yep. Water.
Is that a comma? It's a comma. I'm sorry. That's a comma. This is a comma right here, and this is definitely a decimal, and the others don't have any.
Sprite cranberry?
Oh, those are back in session.
Did you get?
I got some.
Yeah.
Yes.
Did you get an error on C?
Yes.
So we're gonna write not real. I think on my math lab it says non-real instead of not real, but same thing. What is ln of E? 1.
What flavor is
Because
this?
it's
Cherry?
log base E
What,
of
your
E, which is
Chloe, is this cherry?
1.
I don't like it.
I'm definitely
Ellen of
allergic
one?
to cherries. Yes, I am.
Did you get 0?
I'm so serious.
Okay.
I mean, well, it's fake cherry.
Doesn't matter, it's cherry flavor.
So is it cherry or artificial cherry?
Both!
Classified as
It's the
non-real.
flavor, not
So
the
does not exist.
When I'm dying, might as well
But
enjoy this.
I was gonna ask,
what?
or
You'd be allergic to the actual thing.
You can be allergic to both.
Okay,
I'm
go
allergic-
to this
if I'm
slide.
allergic to apples and I drink apple juice, I'm still going to be the fake.
This slide is a little outdated because the graphing calculator has the log base button where you can type the specific base in that's not 10. However, this is important for when we get to 5.4, where you're going to have to write logs out in expanded form, condensed form, and solve them with X in the problem. So while this is not necessarily like this is evaluating it, and you could just type it in your calculator, but we're going to practice changing the base. So this is what I had to learn in high school. if we had a log that was a base other than 10, we had to use the change of base formula in order to evaluate it. It's very simple, and it's actually kind of intuitive because the way you set it up, if you have log base b of m, then you write it as a fraction with two logs, base 10, and the of m is on top and the base is on bottom, which I thought made sense. Base goes in the bottom. So for example, like right here, I'm thinking of the base goes on bottom. Alright, so let's use the change of base formula for log base 5 of 8. You could just type it in the calculator, but we're going to use the change of base formula instead. I see log base 5 of 8. The change of base formula would change that to log 8 over log 5. What is the understood base?
10.
Now, I don't have my graphing calculator up. Let me pull it up. Always. Because the idea was we have it in not base 10 form. We need to change it to base 10 form so we can evaluate it with the log button.
Did you get this fancy little decimal?
You do. Alright, so let me show it to you. So it would be, and there's two ways you could type this. You can just type it out as log 8 divided log 5, or you can do alpha y equals, your little shortcut for fractions, and do log 8 over log 5. You can do that as well. Let me show you all the ways. So log 8. Now, if you do it long, written out horizontally, make sure to close the parentheses at the end of the number. All right, and then what was it? It was math, arrow up, and it was A. 5, 8. Three techniques for writing or evaluating a log.
You hear this?
So 1.292, technically 0, but zero. Yeah. Please tell him you're in math class.
I did.
Go ahead. And then tell him I'm mad at him.
I know. This is weird.
Tell him I'm giving him the stink eye. He's on my list.
Wait.
Which means nothing. Alright. What is Oh, I switched the order. Okay, find the logarithm using the change of base formula. So we're going to do it again. Y'all try it. Is it not switched on y'all's?
It says extra example below it.
Sorry. Jump around. Jump to this one.
Jump around.
Did you write this? Well, you should have. Right?
Fancy little decimal.
Then practice typing it in.
1.2691.
It's not going anywhere.
Did you get 1.2691?
Yes.
Don't you love logs?
How do you use
I
natural
love
logarithm?
logs.
I still hate logs.
I missed that.
Look at the next one. You might think it's the same question we've
Why
already
does it say
done,
natural?
but this time it says to use what?
Natural.
Natural logs, which means
I'm all natural.
they want you, instead of doing base
Presence.
10, they want you to do base E. Did y'all hear that?
Mm.
So if it says find this using natural logs, it means use log base E instead of base 10. So we're going to do this change of base formula the exact same way. It's just going to say log base E 8, log base E of 5. Is he leaving?
So I didn't want to joke around.
Oh, okay. He did so good. Yeah, y'all, strep throat's going around, so please quit drinking that. He's on
You
want some water, Taylor?
Strep is also going around.
And there's a stomach bug.
That's great.
Those are all my tips.
And a motion virus. Yeah, my friend got some kind of virus and they don't know what it is. Like she was
It got all over Taylor's face.
and they don't know what
See,
it
this
is.
is my tip.
Got all over Taylor's face.
There's some
It
virus
busted
in
on
there.
him.
Okay, log base E of 8, log base E of 5. What is log base E? No, I mean what did we, it's ln. So that's ln of 8 over ln of 5. Now you can type that in your calculator. ln 8 divide ln 5. ln 8 divide ln 5.
1.29.
ln.
Like a talk show.
I know, ln. You should notice it's the exact same decimal that we got when we did log 8 over log 5, and that's because they're equivalent.
Huh.
Woo! You're ready for it. That would be, I guess, someone on the stairwell.
That was me. It was me.
Was that you?
Yeah.
Are you kicking the desk? Oh. Go to the next slide and let's look at the graphs.
Come here. Come here.
Don't
Come here.
quit. Don't quit.
Big Mac over here is giving some.
Log base 5
Quarter
of
tons of
x. Here's how you type it in the calculator. Go to y equals. Clear out anything that's in there. What was this? Base
Jamie
5.
walked into Spanish.
You're going to need to pull the log base formula up. So remember how to get that. Math, arrow up. Gosh. Put it right there. We're writing base 5 of x.
Post me.
And then we're going to do zoom 6. That's what it looks like. Kind of looks like the square root graph almost. Which makes sense because logs are the inverse of exponentials. And
Ah! Sorry, I brought my candy cane.
inverse of like x squared would be square root. We can just put it right here, just kind of sketch. This was just to give you an idea of what it looks like. There, you don't have to be, what's the word, exact.
That looks pretty bad.
Go to the next one. Let's look at ln of x. ln of x. So I'm going to leave that one on there, and I'll just type it here. Very similar. Looks like it starts a little further down and kind of shoots higher. So ln of x maybe starts further and like that. If you want it to be accurate, just go to your table and you can get a few points. Which brings us to the next slide where you are evaluating transformations of these
Sorry, I was told to
functions.
open the.
It's the exact same
told to open the
transformations
checkboard.
that we've
But,
talked about
got it.
before. In fact, I've left the graphs up here. Did I leave them for you? No, sorry. You can copy them now. But if you have ln of x plus 3, that is in enclosure. Think of hold up, right? We talked about this. That means hold up, wait a minute, something's different. It's going where? It's a horizontal movement going where? This is actually going to go left 3. Now this one is tricky because it is written in the order that we're not used to seeing. So I would switch it around so you could actually analyze it. We have a lot going on here. We have a negative in the very front, which takes the graph and reflects it over the x-axis. When it's in the very front, that's the one you're used to. That's like the quadratic flipping down. So this is going to reflect over the x. Then you've got a 1/2 in the very front. This is the rubber band thing, right? So big number, greater than 1, means lots of energy to stretch it. Little number less than 1 means very little energy, and it's a shrink because the ceiling and the floor are caving in. Go back to a quadratic. The quadratic, which is normally like this, has less room now because this is caving in, so it's wider. So this is a vertical shrink by a factor of 1/2. And then it's going where? Up, down, left, right? It's going, this is at the very end, not in parentheses. So this is a shift up 3. Go to the last slide. It's a word problem, and you might think, oh, good grief.
Mm-hmm.
How many variables are in the word problem? Please don't say ln is a variable. Ln's not a variable, it's a function. You don't ever plug anything into ln.
3.
One there.
There's 2 W and P.
UPS truck.
You're probably right. I haven't looked, but it's just funny because I thought you were about to sing to him when he said the other.
There's W and there's P.
There you
Yeah,
go.
I saw that.
All right, so look at the word problem. Walking speed. In a study by psychologists, we don't care who, it was found that the average walking speed, W, they're telling you right there what W stands for, and they're giving you the unit of measurement. They're saying it's feet per second of a person living in the city population, P. Bam, they're telling you what P stands for. It's given by this function. We've talked about this. We've said, even though you may hate word problems, there is a common pattern. They tell you the letters, what they mean, and then they're going to ask you to solve for one letter, which means they're giving you the number to plug in for the other letter. You just have to analyze it. It says the population of Billings, Montana is 106,000. Find the average walking speed of the people living in Billings. What did they give me? By the way, this does say population P is in what, y'all? Thousands. Okay. So if it's in thousands, 106,954. 106,954 in thousands would look like this. Now this is tricky. So if I had to say anything was tricky here, I'd say it was this. What did I change? I changed it to a decimal. They're telling you that the P, population, is in thousands. Well, if it's 106,000, then you have to account for the fact that it's in thousands, so that would be repetitive. Does that make sense? This would actually be 106,954,000 thousands instead of just 106,000. You with me? No. If I had, all right, what did I say in math? If you can't understand something that's on grade level, go back down to foundational level and wrap your mind around it and then build up. All right, so if I said this, if I said P was 2, is there 2 people in the city?
There's 2,000.
There it is. How many people are in the city of Billings, Montana? 106,000. But if I write 106,954 with a comma in between, I'm now saying that it's that many more thousands. Like, wrap your mind around this. If P is 2, this means there's 2,000 people in the city. If P is 106.954, it means there's 106,000. You see it
So
now?
basically, you would be saying, like, there'd
You'd be
like
saying there's
over a million.
106,954 thousands. Yeah, there'd be a bunch of zeros after that. So now you just change the population. So, but do you see that trick now? Come down to something simple, wrap your mind around it, and then you can apply the grade level content. All right, so I'm going to go back to this. Okay, so that's the only trick here, is that you've got to be careful with P. Now it says find the average walking speed, which means I'm finding what? I'm finding W when P is what? 954? Is that it? So how do I find it? Plug it in. Plug it into the function. 0.37 ln P.
So we just had to change the format.
You do.
Other than plugging
You just have to be careful. And you should, if you plugged in 106,954 as if it was a comma, hopefully you would realize the number you got was ridiculous. Because you're finding the average walking speed. So I imagine it was 4.3 when it was a comma, from a comma. So, and then now find the real one.
It's 1 point.
Okay, we're talking about feet per second. Is it reasonable for someone to be able to walk 4.3 feet per second? Well, what's your stride like? But no, that's not reasonable.
It might be wrong.
Let's just hold them. Do it again. So I can do it in my head.
Why, so you can make fun of me?
No. Go.
He's gonna what? He's gonna count. I have a long stride.
Alright.
I have big feet. No, I'm nervous now. You're watching.
I'm serious. I got this too. Alright, how long you think this carpet is? Oh. Okay, I was about. How long you think this carpet is?
That's a what? 5x7? That was close.
I think 8.
Hold on. 1, 2, 3, 4, 5, 6, 7. All right, maybe 5x8. 1, 2, 3, 4. It's a 5x8.
Okay, so. You like. Go well?
What's the goal?
He's trying to find your stride length.
What you say? It was just what's up?
Divide by 1,000.
I think it's pretty right. I know what an unrealistic goal is.
I
I think it's.
Per
Very
second.
well.
1.8 feet per second.
I could walk.
Well, what they're doing is they're taking, to measure this, they're taking how many feet they walked in a given time frame, and then they're just giving the average speed.
This is an average person.
Yeah. It's like miles per hour.
This isn't Pierce. Pierce is like half of this.
If you're driving
You're
60
short, Pierce.
miles per hour and
You might walk fast.
60
You're gonna be
minutes
slower
is
than
max,
this.
At least
how
I
many
can.
miles
At least I
have you
can
driven?
walk for that long. I mean, I think you get a little tired after a minute, but.
He's telling you. I know. There's a viral video where the husband from the podcast,
Yeah.
the wife in the car, Yeah, and she cannot, she's like, well, what bus, what are you driving? Is it a bus?
No, I'm not calling trees.
Okay, look at the last one. The population of Chicago is 2.7 million. Find the average walking speed.
Still get the birds.
If it's 2.7 million, what would that be in terms of thousands?
I don't even know.
No, that's crazy.
2,714.
There you go. Basically, move the decimal 3 places over because it's in
Hey.
thousands.
No.
Right,
That's not what you're saying.
like it's almost-
Yes.
That is multi-back.
Yes.
I have one of those.
The one I gave you.
This was right here. Okay.
What'd you get? What'd you get? 3? Okay.
That's my kind of-
Now I am in a I'm in a quantitative statistical analysis class right now.
Uh-huh.
I can already see like a question coming out of this. I want to see if y'all can do it. Can you, without yelling out the answer, because I don't want you to take away your neighbor's thought process. Everybody in here is capable of answering this question. Because I don't even know what Billings, Montana looks like, but I know what Montana looks like. Can you postulate, like formulate in your head, why are the people in Billings, Montana walking 1.8 feet per second? Don't answer out loud. And the people in Chicago, without going political, the people in Chicago are walking 3 feet per second. Don't answer yet. Let everybody wrap
I know
their
why.
mind around it.
It's
I feel like everybody pretty much knows the answer. Why?
because people in Montana drive more. Chicago is more of a populated city.
More people.
Montana is what?
Not gang related.
Rural.
It's really hoping that would say like people know that like they said, if you stop,
Yeah.
Latin keys.
Montana is rural, and Chicago is
Urban.
definitely urban, fast-paced. You know, people are like, I have an appointment, I have a meeting. Montana, most of the people in Montana are farmers, ranchers. I mean, that's not to say there's not business people
They just
there,
chilling.
I want to live in Montana.
but they're not in a hurry, right?
All
right.
He's out here in his birthday suit, jumping around doing jumping jacks.